Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 21 to 27 of the January 2016 Algebra 2 Trig Regents exam. If you have any questions, just feel free to place your questions in the comment section below, and we'll be glad to support you at our earliest convenience. All right, let's take a look at 21. It says, if the terminal side of angle theta passes through the point -3, -4, what is the value of secant theta? So when you're dealing with the determination of trig ratios using coordinates of the terminal side, you always want to sketch the situation, okay? The benefit of sketching the situation is that you have a visual that can help you accurately create your related right triangle, and then you can also make good use of your trig ratios in determining the correct ratio. So -3, -4, 1, 2, 3. Well, let's see. Okay, that's -3. On the x, on the y, we have 1, 2, 3, 4, -4. That's the point right there. And angle theta goes through that point. Now, we have to draw angle theta correctly. So where is angle theta? Angle theta is a reference angle. You always draw your reference angle from the terminal side to the closest x-axis, okay? The closest x-axis in this case is the -x. So this right here is the reference angle we're going to be using to create our trig ratio, okay? So there goes our right triangle. Now what I'm going to do is I'm going to extract that right triangle so we can really focus in on the mathematics without getting confused with the different things happening in that coordinate sketch, okay? Now, let's just say this is the right triangle that I have over here. This is -3. This is theta. And this length right here is equivalent to that length, so this is -4. Okay? Now, we have to find secant theta. Secant theta, we don't know what secant theta is. If we reciprocate secant, secant is related to what? Using our reciprocal identities, we know that secant theta is equal to the reciprocal of cosine. Okay? So that's one fact we want to keep in mind. Now, this is a mnemonic device that will help us solve this problem, and that is Sohcahtoa. Sohcahtoa. Sohcahtoa only tells us sine, cosine, and tangent, but if we reciprocate sine, cosine, and tangent, we could get the other three. Which one are we going to be focusing our attention on in this problem? Cosine, because its reciprocal is secant what we're looking for. Okay, so from this ratio, we can see that cosine, use a pen, cosine theta is adjacent divided by hypotenuse. Now, if cosine is adjacent divided by hypotenuse, its reciprocal secant is what? Hypotenuse divided by adjacent. So if I can find my hypotenuse and adjacent in this right triangle, I am good to go. Okay, now, let's see. If this is the angle, then the side opposite the angle is called what? The side opposite the angle is your opposite. The longest side is side opposite the 90-degree angle. That's your hypotenuse. We don't know what that is. And then we have our adjacent over here. Our adjacent is -3. Okay, so we know A is -3. Now, how do we find H? This, ladies and gentlemen, is a right triangle. So whenever you're given two sides of a right triangle and you want to find the last side, you can always use the Pythagorean theorem. Okay, so let's call this AB. C is always a hypotenuse. Okay, so what I'm trying to do now is I need to find C. How do we find C? Well, we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So we have -3 squared plus -4 squared equals c squared. Now, if I square these two, I get 9 plus 16 equals c squared. 9 plus 16 is 25, and this is c squared, root both sides, and you get 5. C is equal to 5. Now, some of you might have already guessed that c is equal to 5 because what you have here is a Pythagorean triple 3, 4, 5 triangle, but using the Pythagorean theorem just confirms that result. All right, so h is 5. H is 5. Adjacent A is -3. And secant from the reciprocal of chi, Sohcahtoa, is hypotenuse over adjacent. So we're going to plug it in here, and then our answer is going to be 5 over -3. Option number 2 is the correct answer for this problem. All right, let's take a look at number 22. It says when the inverse of tan is sketched, its domain is. So one thing you want to recall, let's write that down real quick. Recall that the domain is the horizontal span of your graphical representation. Okay, is the horizontal span. All right, if I project of the graph of the function, if I project the graph onto the x-axis, whatever linear inequality scenario I have there, that's going to be the domain of the function. All right, so this is a pretty straightforward problem. We're looking at the inverse of tan, which is tan to the -1. Since we can use our calculators here, we're just going to graph this function and then look at what the domain is. All right, so let's go ahead and graph the inverse tan function. Second function tan will give you the inverse tan function of x. Graph it. Okay, so that's what the inverse tan function looks like. Let's go ahead and sketch it right here. It should look familiar to you. That graph should look like a portion of a function that you already know how to graph. So something like that, and then it goes something like that. All right, this is basically the tan function reflected along y equals x, okay? So what is the projection of this graph onto the x-axis? If I project the right side down and project the left side up, I'll end up with this inequality right here. Bam. You go forever to the left and forever to the right and everything in between. What is the equation of this inequality I have here? The equation is you're going from the left end, -infinity, all the way to the right end. There's no break. So you're going from -infinity, it's less than theta, and theta is less than infinity. In this case, is x. Let's put the correct notation there. -infinity is less than x, and x is less than infinity. So this is your domain. The domain is basically all real numbers. Okay, so domain of your inverse tan function is -infinity less than x. X is less than infinity. Answer is option number 4. Okay, let's take a look at number 23. We're going to be using recursive definition of a sequence to generate terms of a sequence. In this case, we're looking for the third sequence, okay? So just a real quick caution that I want you to keep in mind. Whenever you deal with negative numbers, use parentheses. Use parentheses is for your protection. Use parentheses to avoid sign errors. Okay, I'm going to illustrate that for you in this example. Okay, so we're looking for A3. So we want to find A3. So we have to start from scratch. The first term is A1. A recursive definition of a sequence is basically a sequence where subsequent terms are determined by using an initial term and a formula, a recursive formula, okay? So if we want to find the second term, we have to use the first term and the formula to determine what the next term is going to be on the second term. Okay, so initial term is -6, so we have a2 is going to be 1/2 an minus 1. What is n here? N is 2, right? The index a2 minus 1 minus 2. Okay, so you see n, if you have 2 here, you put 2 there. That's what we're doing. Okay, so this is going to become 1/2 a1 minus 2. Now, what on earth is a1? Well, we have the initial condition here. So we're going to compute 1/2 parenthesis -6. This is what I was talking about. When you're carrying out substitution, always use parentheses to avoid making sign errors. Okay, it's a good practice. Now, we're going to have -6/2 minus 2. Using order of operations, -6, you divide first, you have -3 minus 2, which is -5. This is the second term. We're asked to find the third term, a3. Using the recursive formula, is 1/2 of a 3 minus 1 minus n, which is 3. Okay. Let me make a note here. So for a3, n is equal to 3. And then for a2, n is equal to 2. Okay, let's simplify this. We are going to now have 1/2 of a2. See the recursive relation happening here. a3 is dependent on the term before it, minus 3. Okay, so we're going to have 1/2 of a2, which is -5, minus 3. Okay, looks like we have to do some fractions here. Half of -5 is split over 1, multiply across, you have -5/2 minus 3. Put this over 1, let's combine these two fractions. The LCD of 2 and 1 is 2. So we multiply 3/1 by 2, so we have identical denominators. So we have -5/2 minus 6/2. Same signs, add and keep the sign of the, just keep the sign. -5 minus 6 is -11/2. Final answer is option number 1 for question 23. All right, let's look at 24. It says, what is the equation of a circle with its center at 0, -2, and passing through the point 3, -5? So we're going to be using the center radius form of the equation of a circle to assist us here. So let's write down some formulas. So the first one is the center radius form of the equation of a circle, x squared, sorry, it's x alone, x minus h squared plus y minus k squared equals r squared. Okay, so this is the final step. We also need to know our distance formula. Given 2 points, how do you compute the distance? The distance is basically the square root of x2 minus x1 squared plus y2 minus y1 squared. This is basically the Pythagorean theorem in coordinate format. Now what's happening here is that we have a circle with this center going through this point. So in order for us to write down the equation of a circle, all we need is the center radius equation right here. We need h and k, the center and the radius. The beautiful thing about this problem is we already have the center. So this is my h and this is my k. We're missing the radius, so how do we find it? Now, let me give you a visual. This is not necessary, but I just want to give you a visual of the situation so that you can understand exactly why, how I'm proceeding the way I'm proceeding, okay? So we want to graph the center first, 0, -2, 1, 2. That's the center. And then it goes through a point 3, -5. 1, 2, 3. 1, 2, 3, 4, 5. Down. Okay, so we have a circle. And we need to find the radius. The radius is the distance between these 2 points. So if I can figure out that distance using the distance formula, then I am good to go. Okay, all right, so let me graph this for you. Center, -0, -2, radius. Okay, so our radius, we're going to be using the distance formula. 3, -5, let's call this x2, y2. And then let's call 0, -2, x1, y1. It doesn't matter how you label it, okay? Just make sure that the two values have the same index, the 1s and the 2s, okay? Now, the radius. What is the radius? So applying the distance formula, r is going to be the square root of x2 minus x1. So x2 is -5 minus x1, which is 0, square, plus y2, -5 minus y1, -2, square that. Okay, and then let's simplify. So we have the square root of -5 minus 0 is just -5 square, plus -5 minus minus slash and dash, this becomes a plus. This is -3. -3, okay, I made a mistake. x2 is not 3, x2 is x2 is positive 3. I don't know why I put a 5 there. Okay, so x2 is 3. Okay, x2 is 3 minus 0. x2 minus x1. Okay, so 3 minus 0 is 3. Sorry about that. Okay, and then they take the square root. This one is also squared. Proceeding, we're going to have the square root of 3 squared, which is 9, plus -3 squared is positive 9 because minus times minus is plus. So we have r is equal to the square root of 18. Okay, let's leave it like this because we're going to be squaring it more entirely. So we have everything that we need. Okay, since the center is 0, -2, that follows that h is 0 and k is -2. Okay, and then we also have the radius of root 18. Now we're going to put everything into the equation on the center radius form of the equation of a circle. So let's rewrite it here so we don't make mistakes in our substitution. I always like to write down formulas first before I substitute to reduce the chances of making mistakes. Okay, so we have x minus h0 squared plus y minus k. So you want to be careful here because you have two minuses. Minus, minus, square plus the radius, which is root 18 square. Okay, if we simplify this a little bit, let's see what we get. We get x minus 0 is just x, right? So we have x squared plus y minus times minus is plus two quantities squared. If you square the square root, what happens is that they cancel each other out. So you're left with 18 as the square of your radius. Okay, so this is the equation of the circle with center 0, -2 going through 3, -5. Answer is option number 3. That's the correct answer for this problem. All right, let's take a look at number 25. It says if angles A and B are complementary, then secant B equals. Now, if you remember your identities, you automatically know that the answer is option number 1. But let's assume that we don't remember our identities, okay? So complementary angles are angles that add up to 90 degrees. If you're thinking about an easy way to visualize complementary angles, just create a right triangle, okay? One of the angles is going to be, let's say this angle is B, and this is A. Since this is 90 degrees, guess what? A and B are automatically complementary. Okay, so I'm gonna use this triangle to help me solve the problem. So with reference to angle B, in this case, if this is angle B, this is going to be my opposite. This is going to be my hypotenuse. And this is going to be my adjacent. Now, what helps us to connect the ratio of two sides to an angle? Sohcahtoa, right? Like we used in the previous problem. So I want to create secant from Sohcahtoa. I have no idea what that is because secant is not in Sohcahtoa. You just have sine, cosine, and tangent. But cosine is related to secant. We talked about this earlier. So cosine B is adjacent. Where's my adjacent? Okay, you know what? Let me use little alphabets to assist us here. So let me call this little a, call this little b, call this little c. Okay, so cosine is adjacent over hypotenuse, which is adjacent little a over little c. Okay, so that's what cosine is. If this is cosine, then what is secant? Well, secant is the reciprocal of cosine, which is c over a. Okay, now, since a and b are complementary, what you want to note is that a plus b is equal to 90 degrees. So if I get a by itself, a is basically 90 minus angle b. Okay? Okay, so now I just made a copy of this triangle. I'm going to focus my attention on angle A. Okay, and then when I'm done creating my ratio, I'm going to see, replace it with 90 minus B, and then go from there. Okay, so let's mark this angle right here. Angle A is our reference angle now, since A and B are complements of one another. So in my new construction, this is now my new opposite. Okay, this is my hypotenuse that is independent of the angle, and then this is the adjacent right here. Okay, I like to replace it with little letters, so let's call this little c, let's call this little b, and let's call this little a. All right, back to the question. It says secant b is equal to what? Secant b is equal to what? So we can just test it out. We have cosecant and we have cosine. But we're looking for the complement, so we're looking for 90 minus b. So we can eliminate option 2 and option 3 because their angular orientation are off. We need 90 minus b. So it's either cosecant or cosine. Which is the correct one? Well, let's test cosecant first. What is cosecant? I have no clue. But I know that sine from sine of A is opposite over what? Hypotenuse, right? From in Sohcahtoa, which is A over C. Now, if sine is A over C, guess what? Cosecant is its reciprocal, which is C over A. Wait a minute, that is exactly what secant is, okay? So since secant is B, secant B is C minus A, since, let's write this down, since A is equal to 90 minus B, from this equation it follows that cosecant cosecant 90 minus B is equal to C minus A. So our answer for this problem is option number 1. Cosecant A is equal to secant of angle B. All right, let's take a look at question number 26. It says the legs of a right triangle are represented by x plus root 2 and x minus root 2. The length of the hypotenuse of a right triangle is represented by, so let's give ourselves a visual. That's always helpful whenever you are talking about a geometric figure presented in text format, okay? The beauty of giving yourself a visual is that you are less likely to make errors when substituting components into your related formula. Okay, so let's draw ourselves a right triangle here. We know that the legs are A and B, so let's call this one leg A, x minus root 2, and then B, the other leg, x plus root 2, and then C is your hypotenuse, okay? So the question asks, what is the length of the hypotenuse? So we're looking for C. So we want to find C. Okay, what is a formula that relates the three sides of a right triangle? Pythagorean theorem, right? So the formula we're using is a squared plus b squared equals c squared. Okay, so we're gonna have a squared is x minus root 2 squared plus b squared is x plus root 2 squared equals c squared. So the goal here is to get c by itself, and that will be our final answer. Okay, so let's expand these binomials. We have x minus root 2 times x minus root 2 plus x plus root 2 times x plus root 2 equals c squared. Okay, so we can just pull this out first, outer inner last, no problem. We have x squared minus x root 2 minus, so x minus x root 2 minus x root 2 minus root 2 squared. Okay, and then the same goes for the other one. Just gonna follow that out too. So plus first x squared, outer plus x root 2, inner plus x root 2, last plus root 2 squared, and that's equal to c squared. Kind of run out of space here. Okay, so let's combine like terms. So we're gonna have x squared. These two are okay. Let me go over here and work this out so you don't get confused. X root 2 minus x root 2 minus x root 2. What you're doing is you just add in the coefficients. Okay, don't add the radicands. When you add minus x root 2 and minus x root 2, it's as though you're adding one, you're subtracting 1x from negative 1x. What do you get? Negative 2x root 2. Okay, so that's how you combine these two middle terms. Kind of tricky. Okay, so you have negative 2x root 2. Okay, minus, when you square the square root, they cancel each other out. You're left with the radicand, 2, plus x squared. You combine these two, it's the same story that we told over here. What is x root 2 plus x root 2? All right, just add the coefficients. So it's just 2x root 2. Okay, so we have plus 2x root 2. And then when you square the square root of 2, we get 2 equals c squared. Now, one interesting thing that happens here is that, oh, I made a mistake. Last, when you do minus times minus, this is a plus. Okay, so this is a plus right here. Okay, so when one interesting thing that's going to happen here is that you're going to see some cancellation happening. Negative 2x root 2 and positive 2x root 2 are opposites. So when you add them together, they cancel out. So when you combine x squared, like terms, you have 2x squared. And then when you combine, what else do we have? Positive 2 and positive 2, you have plus 4 equals c squared. Now, to get c, the length of the hypotenuse isolated, you're just going to do the inverse of square, which is square root. So root both sides and you are in business. Final answer, little c, the length of the hypotenuse is 2x squared plus 4. Our answer is option number 1. Okay, let's take a look at problem number 27. It says, what are the amplitude and period of the graph represented by the equation y equals negative 3 cosine theta over 2? So there's one little trick that can help you eliminate distractors from this problem. So let's side note. Amplitude is always positive, okay? Think about it as a scalar quantity is a length. There is no way you can have a negative amplitude. Okay, with that in mind, can you eliminate any options here? The answer is yes. You can immediately take out 1 and 2 because they have negative amplitude values. Okay, all right, so let's go ahead and solve the problem. This is the formula we're going to be using for y equals a cosine bx, a cosine bx, the amplitude is equal to the absolute value of a, and the period is equal to 2 pi over the v value. Okay, so in order to compute our amplitude and period, all we need is to extract the correct values for a and b from this equation, and we're good to go. Okay, so we have change the color here. We have y equals -3 cosine. Now the variable, the independent variable is theta. What's been multiplied by theta here? Imagine that you have a 1. That's multiplied by identity. So what you have is 1/3 theta. Okay, that's how you express the angular argument of the cosine function. All right. Okay, so our amplitude is what? Well, to assist us, let's extract a and b first. So a is the coefficient of a cosine, which is -3, but we need that. Yeah, so a is -3, and b is the coefficient of the angle, so that's 1/3. Okay, just to make it obvious what I'm doing, y equals a cosine bx. All right, so that's a right there, and then that's b right there. All right. Okay, amplitude. Amplitude formula for amplitude is the absolute value of a. So remember, the absolute value of a number can never be negative. Okay, measuring distance here. So absolute value of -3 is +3. That's how far -3 is from 0 on the number line. Period. Period can be determined by computing 2 pi over b. Okay, so we have 2 pi over b is 1/3. Now this is a complex fraction. Looks terrible. How can we rewrite it in a simpler format? All we do is we drop, change, flip, multiply the numerator by the reciprocal of the denominator, which is 3/1, like that, and then you multiply it across, and there goes your period. Okay, period is 6 pi, and your amplitude is +3. Option number 4 is the answer to this problem. Thank you so much for taking the time to watch this presentation. I appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. Your positive feedback is very important to us. Don't forget to subscribe for updates to the remainder of this review series. If you have any questions, just include it in the comment section below, and we'll be glad to support you at our earliest convenience. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.